Now let's talk about the numeric data types. The information that is stored and manipulated by computer programs is referred to as data. Data can be numerical, text, or some other complex type. So in this lecture, we'll only talk about the numerical data types. There are two different kinds of numbers. One, the whole numbers, such as 5, 4, 3, 6, and they don't have a fractional part. And the second numerical data type is decimal fractions, such as 0.25 or 0.10 or 3.14. Inside the computer, whole numbers and decimal fractions are represented quite differently. We say that decimal fractions and whole numbers are two different data types. Whole numbers are represented using the integer data type, or int for short, and these values can be positive or negative whole numbers. Numbers that can have fractional parts are represented as floating point values, or float for short. The data type of an object determines what values it can have and what operations can be performed on it. How can we tell which is which? A numerical literal without a decimal point produces an int value, and a literal that has decimal point is represented by a float even if the fractional part is 0. So why do we need two number types? Values that represent counts can't be fractional, so you can't have 3.5 quarters, for example. Most mathematical algorithms are very efficient with integers. And the float type stores only an approximation to the real number being represented. Since floats aren't exact, use an int whenever possible. And finally, Python does not have explicit type declarations. This means that the type of the variable will be dynamically assigned based on the value that is being assigned to it. It also means that the data type of a variable can dynamically change. So let's see some examples in the editor. Now let's do some operations on the numeric data types. So first, operations on integers produce integers, and operations on floats produces floats, and except for the division. So let's see some examples. So a float plus another float value will result in a float value, and an integer plus an integer will result in an integer. The same rule is valid for the multiplication, and for the division, a float divided by a float is a float. However, an integer divided by an integer is also a float. Python has another division which is called integer division, that is represented by 2 forward slashes or 2 division signs. So in this case, 10 integer 10 divided by integer 3 is an integer. So we only get the integer part. So let's do this in the Python shell. So here I have my terminal window is open, and I am in my CIS6 folder, and you can also see it from the graphic user interface that I am here in my CIS6 folder. And if I list what I have in this folder, I have lecture 1, 2, and 3. So I'm going to jump into my lecture 3 folder. Again, for this part of the program, we don't have to be in anywhere. All we have to do is execute Python with Python 3 and hit enter. So here I have the Python shell open, and I'm gonna do some operations on the number types. So first, I'm gonna do an integer plus an integer, and you have seen this many times already. And I'm gonna do 3.5 plus 4.5. So a float plus another float is a float. So what we didn't see is that if you have an integer plus a floating point number, this is a mixed type. So we have an integer plus a float. So here an integer plus a float will result in a float value. And the reason for this is that a float is a larger number set than integer. And if Python ever see a mixed match of integer and floats, it will automatically convert the integer to float and do the operation on two floats. The reason for that is that converting from integer to float, we won't lose the data. However, converting a float to an integer, we will most likely lose some data. So let's do division as well. So I'm gonna say 10 divided by 3, and I will get a 3.33. We have 15 numbers here, so floating point supports 15 decimal precisions. So if I ever want to do, and if I'm interested in the integer part of the division, I can use the integer division or double division. All right, so again, if I do a 3.0 times 1 or vice versa, if I say 4 times 1.0, the result will be 4.0. Alright, so if you go ahead and try this on your own, and if you're interested, you can test more numerical operations.